So this is the continuation of our lecture in EE 121 under Chapter 2. We have Resistivity. So I posted another YouTube video in your MVLE explaining further for this resistivity. So resistivity is symbolized by the Greek letter Rho. It merely indicates that it is the resistance of the given conductor material having unit length and unit cross-section. So, resistivity is applied to the resistance of a substance having a unit dimensions of length and cross-sectional area. Conductors are round and small in diameters. It is convenient to express in mils. So, as you can see, some conductors or the common conductors used is so small in diameter, so this diameter is indicates or expressed in what we call mils. So 0.001 inch is equivalent to 1 mil, or 1000 mils is equal to 1 inch. Circular mil or circular units rather than square units to denote cross-sectional area. Area of a circle 1 is circular mil, and if it is diameter is 1 mil. So we will denote area of a conductor, that is the circular mil, and the diameter of the conductor is what we call mil. So these are some formulas related to resistivity in SI unit and in English unit. So in SI unit, we have the area that is equal to area of a circle pi r squared, or A is equal to pi over 4d squared if the diameter is given here, and if the radius is given here, use this formula. Of course, the diameter is in centimeter, millimeter, and so on. Rho is in ohm centimeter. And this rho is our resistivity, that is equal to our area, the unit is square meter, and the resistance in ohm divided by our length in meter. So that is AR over L, ohm meter. In English unit, we have the area that is equal to D squared. D is in mils and A is in circular mils. Rho is in ohm circular mil per foot. So we will denote circular mil as big letter C and big letter M. So this will be the conversion if our given parameter is in inches squared. So 1 cm or 1 circular mil equal to pi over 4 times 10 raised to negative 6 square inch. So remember the difference between SI unit and English unit. The diameter here is in centimeter, millimeter, and the diameter in English unit is in mils. The area is in SI is just the formula in getting the area of a circle, while in the area of an English unit or in English unit is circular mil, that is D squared. So resistivities of common elements and alloys at 20 degrees Celsius. So for silver, that is 9.9. All of these numbers are expressed in English unit. So that is 9.9 ohm circular mil per foot. In copper annealed, that is 10.37 ohm circular mil per foot, and so on and so forth. So if the problem is not specified, example, it is just written as copper, it is also considered na annealed yun. Okay, no copper lang timbaga na dyan problem, annealed. So copper hard drawn is 10.65 ohm circular mil per foot. until mercury is 577 ohm circular mil per foot. Another one is in alloys, that is brass, 42 ohm circular mil per foot, up to chromel, that is 625 to 655. Loss of resistance. So the resistance are offered by a conductor depends on the following factors. So number one, it varies directly as its length L. So as the length changes, the resistance also changes. So nung umato ni resistance, nangatomet iti or atidugmet iti length ni wire or conductor. No ababan ni conductor, it lowers also the resistance. So it varies inversely as the cross section A of the conductor. So low R, larger A, high R, lower A. So we will see that later when we will solve problems. It depends on the nature of the material. So dependent on copper, silver, and so on. It also depends on the temperature of the conductor. So we have two conductors here, A1 and A2, and smaller length, larger area, so you will end up lower resistance. Larger length, smaller area, and you will have a greater resistance. Remember, the resistance is directly proportional to conductor length, and resistance is inversely proportional to the cross-sectional area. So in SI unit system, we have this one is the resistivity that is equal to A squared R over L. So this is in SI. If we are going to solve for the resistance, that will be equal to R equal to rho L all over A squared. And your rho in SI unit is in ohm meter, area is in square meter, and the length is in meter. Other formulas, we have the resistance equal to rho V over A squared, and R is equal to rho L squared over V. So we will solve examples. Let's solve number 1. So using the given particulars, calculate the resistances of the following conductors at 20 degrees Celsius. So a while ago, we discussed or we have seen the table which has a temperature of 20 degrees Celsius. For letter A, we will solve the resistance of a material given that is copper and it has a length of 1,000 feet, circular mil or area of 3,220 circular mils. Letter B is aluminum and the length is 4 miles, diameter is 162 mils. Letter C is material advanced, the length is 486 inch, diameter is 0.0159 inch. So for letter A, we have a resistivity of a copper equal to 10.37 ohm circular mil per feet or per foot. The length of the wire is 1,000 feet and the area is 3,220 circular mil. The formula in getting the resistance is equal to the resistance equal to rho multiplied by the length divided by the area. So the resistivity is 10.37 ohm circular mil per foot times 1,000 divided by 3,220 circular mil. So cancelling circular mil and circular mil, foot and feet, so we will end up 3.2205 ohms. Letter B. So for aluminum, the resistivity of the aluminum is 9.9 ohm circular mil per foot. The length of the wire is 4 miles. So kailangan natin ang feet. So we will convert miles to feet. 1 mile is 5,280 feet, and the length of the conductor now will be 21,120 feet. For the area of the conductor, since our diameter is expressed in mils, so getting the area of the conductor, that is d squared, equal to 162 squared, that is 26,244 circular mil. Solving now the resistance, that is 9.9 times 21,120 divided by the area, which is 26,244. The resistance of the wire now will be 7.9671 ohms. For letter C, we have a resistivity of the conductor, which is advanced, 294 ohm circular mil per foot. The length is expressed in inch, and we will convert this one into feet. So we have 40.5 feet. The diameter is expressed in inch, so we will convert inch to mils, and 1 inch is 1,000 mils. The diameter of the conductor now will be 15.9 mils. Getting the area of this conductor, d squared, so 15.9 squared, that is 252.81 circular mil. Solving now the resistance, equal to 294 ohm circular mil per foot times 40.5 feet divided by 252.81 circular mil. The resistance now of the wire is 47.0986 ohms. Number 2, the substation bus bar is made up of 2 inches round copper bars, 20 feet long. What is the resistance of each bar if resistivity is 1.724 times 10 raised to negative 6 ohm centimeter? So this is centimeter since it is not capitalized. Therefore, this is an SI unit. The diameter of the conductor is 2 inches. The resistivity is 1.724 times 10 raised to negative 6 ohm centimeter, and the length is 20 feet. So we will convert this diameter and length into SI unit. So diameter is equal to 2 inch times 2.54 centimeter in 1 inch, equal to 5.08 centimeter. Now the area of the conductor is pi over 4 d squared. So that is 20.268 square centimeter. The length is 20 feet times 34.48 centimeter divided by 1 foot. That is 609.6 centimeters. So we can get now the total resistance, equal to 1.724 times 10 raised to negative 6 ohm centimeter times the length all over the area. So we will get 51.853 micro ohm, or 51.853 times 10 raised to negative 6 ohms. So the resistance of each conductor will be our total divided by 2, that is 25.926 micro ohm. Number 3, a copper wire whose diameter is 0.162 inch has a resistance of 0.4 ohm if the wire is drawn through a series of dies until its diameter is reduced to 0.032 inch. What is the resistance of the lengthened conductor? Assume that the resistivity remains unchanged and it has the same volume. So we have diameter 1, that is 0.162 inch. Diameter 2 is 0.032 inch. And our resistance 1 at diameter 1 is 0.4 ohms. So since D1 is larger than D2, we will expect R2 to be larger. From our formula, the resistance is inversely proportional to our area. So no nangato detoy area nababati resistance, but if your area is lesser, so your resistance is higher. So in this problem, we can see that that D2 is reduced. Therefore, our resistance will be higher than R1. So our condition here is the volume is the same. V1 is equal to V2, and also the resistivity is the same since it uses the same conductor, that is copper. So from here, the resistivity multiplied by the volume is equal to RA squared. So resistivity 1 times V1 is equal to resistivity 2 V2. Therefore, R1 multiplied by A1 squared is equal to R2 A2 squared, where your A is equal to pi over 4 D squared. We will substitute this area here dito sa A1 and A2. So, magiging ganito. Then, we will equate R2 all over R1 equal to pi over 4 D1 squared parenthesis or bracket squared divided by pi over 4 D2 squared squared. So, cancel yung pi over 4 and pi over 4. Squared times squared is raised to 4. Same at the denominator. So, R2 over R1 is equal to D1 raised to 4 divided by D2 raised to 4, or the parenthesis of D1 over D2 raised to 4. So, we can now solve R2. R2 is equal to R1 D1 over D2 raised to 4. So, our R1 a while ago is 0.4. D1 is 0.162 divided by 0.032 raised to 4. So, R2 is 262.736 ohms. So, as you can see here, our D2 is reduced. So, the resistance became larger or greater compared to R1 that is 0.4 ohms.